Lesson 37, Chemical Compounds and Parallelograms. This is a two-part lesson. We're going to start with chemical compounds first. If you've taken chemistry, or you are taking chemistry, or you will take chemistry, this is important information that you will use. Some that have already taken chemistry, we've already done something like this. But for those of you who haven't taken it yet, this would be good prep for you. One thing that we need to know, because we are dealing with chemical compounds, and this is from science perspective, atoms combine in the same combinations when they unite to form a specific compound. For example, water. Water is H2O. It can't be H3O. That would leave us with a different kind of chemical combination. Water is always going to be found in the combination H2O. Because of this, every atom also has a different weight. Okay, so every atom has a different weight. For example, the weight of oxygen. Every atom of oxygen has an atomic mass of 16 grams, or weight of 16 grams. Hydrogen. Every molecule of hydrogen has a mass or has a weight of 1 gram. So when we're talking about water, which is H2O, we have 2 molecules of hydrogen, 1 molecule of oxygen. Each hydrogen weighs 1 gram. So if we have 2 hydrogen atoms, each weighing 1 gram, the total weight for all of hydrogen in water is 2 grams. We have 1 atom of oxygen, and each atom of oxygen weighs 16 grams. So the total weight for oxygen in H2O is 16 grams, which means the total weight for each molecule of water is going to be 18 grams. Let's use this to do some examples. At this time, you'll need your example sheet. Let's look at example 1. It says the chemical formula for water is H2O. If we have 3,600 grams of water, what is the weight of the oxygen? The way that we're going to solve these problems is to set up a chart. Setting up a chart is probably going to be the easiest way to do this. The first, we're going to set up a chart. We're going to have 3 columns in it. The first column is going to be the element itself. The second column is going to be the weight in grams. And the third column is going to be the weight of the solution. All right, so we are looking at chemical formula for water. The elements that are involved in water are hydrogen and oxygen. Okay. And then we're going to end up with a total because they combine to form water. Hydrogen, there are 2 grams of 2 molecules of hydrogen, each weighing 1 gram. The weight will always be given to you in the problem for these. The weight of hydrogen is 1, and since there's 2 hydrogen atoms, each weighing in at 1, the weight in grams for hydrogen is 2, as previously mentioned. There's 1 atom of oxygen, that should be at 16, weighing in at 16 grams. So the total weight in grams for oxygen is 16. Meaning the total weight for H2O is 18 grams. Then we're dealing with a solution. We have, in the problem, it says if we have 3,600 grams of water, what is the weight of oxygen? So we know down here when we're finding the weight of the solution, our total weight of the solution is 3,600 grams because that's how much water we have. We are looking for the weight of the oxygen. At this point, the hydrogen is not needed. We just need the hydrogen to find the total. We are going to use this information oxygen to the total, and we're going to set up a ratio. And we're going to cross multiply and divide in order to solve. So we're going to pull this information out, make it into a ratio, and solve our problem. So our ratio is going to look like this. 16 over 18 is equal to x over 3,600. And in order to solve this, we're going to cross multiply. 18 times x is 18x. 3,600 times 16 is 57,600. And we're going to divide by 18 to find our weight in grams of the oxygen in H2O. So if we divide by 57,600 by 18, x is going to equal 3,200 grams. So the answer for this problem is 3,200 grams of oxygen. Let's take a look at example 2. Example 2 says the chemical formula for ammonia is NH3. This tells us that each ammonia molecule contains 1 nitrogen atom and 3 hydrogen atoms. If we have 510 grams of ammonia, how much does the nitrogen weigh? Again, we want to go ahead and set up our chart with our 3 columns. We have our elements, weight in grams, and our solution. The elements that we're dealing with are nitrogen and hydrogen, and they come up with a total for our ammonia. Notice in the chemical formula NH3, there's only 1 nitrogen atom, and each nitrogen atom has a weight of 14 grams. So our weight in grams for nitrogen is going to be 14. In the chemical formula for hydrogen, there's 3 hydrogen. Each hydrogen weighs 1 gram. So our weight in grams for hydrogen in NH3 is going to be 3, which brings our total to 17, because 14 plus 3 is equal to 17. Now, in the problem it says we have 510 grams of ammonia. That means our total weight of the solution is 510 grams. We want to know how much does the nitrogen weigh. So we are looking for nitrogen, and hydrogen at this point becomes obsolete. We are going to use this information about nitrogen and the total to set up a ratio and to solve. So we're going to plot this information. 14 is to 17, and that's equal to x over 510. Now to solve, we cross multiply and divide. 17 times x is 17x. 510 times 14 is 7,140. If we divide by 17, x is going to be equal to 420 grams. So the weight of nitrogen is 420 grams. Go ahead and try example 3 on your own. Pause the video, and when you have come up with a solution, hit play to see if your solution matches mine. Okay, in number 3, it says the formula for ammonium chloride is NH4Cl. This means that in 1 molecule of ammonium chloride, there is 1 atom of nitrogen, 4 atoms of hydrogen, and 1 atom of chlorine. How many grams of chlorine are there in 1,060 grams of ammonium chloride? First thing you should have done is set up your chart. Again, you should have your 3 columns, your elements, your weight in grams, and the weight of the solution. Now, in this one, we have 3 different elements. We have nitrogen, hydrogen, and chlorine. And all 3 of those are going to come up to add up to a total to give us a solution of ammonium chloride. Now, in ammonium chloride, there's only 1 nitrogen atom, and each nitrogen atom has a mass in grams of 14. There are 4 hydrogen atoms. Each hydrogen has a mass of 1, so the total mass of hydrogen is 4. There's 1 chlorine atom, and the mass of each chlorine atom is 35. So 35 is the weight in grams for chlorine. If we are adding these up and totaling them, our total comes to 53 grams. That is for 1 molecule of ammonium chloride. The problem asks how many grams of chlorine are there in 1,060 grams of ammonium chloride. So in the total column for our solution, it should be 1,060 for our grams of ammonium chloride. We want to know how much chlorine is in that. So this is what we're going to use to set up our proportion. So our proportion should look like this. 35 is to 53, and that's equal to x is to 1,060. Again, to solve a proportion, you should cross multiply and divide. 53x is equal to 37,100. Divide both sides by 53, and x is equal to 700 grams. Let's move on to part 2 of our lesson. Part 2 is talking about parallelograms. There are 4 specific special properties that we want to list for parallelograms, and these will help us to solve problems with parallelograms. All right, so they have 4 special properties. Property number 1. Pairs of parallel sides have equal lengths. Pairs of parallel sides have equal lengths. Number 2. Angles opposite each other have equal measures. Angles opposite each other have equal measures. Property 3. The sum of any 2 adjacent angles is 180 degrees. The sum of any 2 adjacent angles is 180 degrees. And property number 4, diagonals bisect each other. So property number 1, pairs of parallel sides have equal lengths. Property 2, angles opposite each other have equal measures. Property 3, the sum of any 2 adjacent angles is 180 degrees. Property 4, diagonals bisect each other. And keep in mind, when we say bisect, that means to split in half. So let's look at an example using these 4 properties of parallel. Take a moment and copy this example down. If you need to go ahead and pause the video at this time, you can. Notice we are solving for x, y, the measure of angle BCD, which is this angle here, and the measure of angle DAB, which is this angle here. Let's start off with solving for x. Now notice that x is a diagonal. Now, in our properties, property number 4 stated that diagonals bisect each other. So this diagonal here is bisecting this diagonal here, which means that this half is going to be equal to this half. So we could say that x plus 2 is equal to 6, which means that x is going to be equal to 4. We could also say that this diagonal is equal to this half, which means that 2y minus 4 is equal to 8, which means that y is going to be equal to 6. The next thing we need to solve for is the measure of angle BCD, which is this angle here. There are two properties in our properties of parallelograms that talk about the angles in parallelograms. The first one is property 2. Angles opposite each other have equal measures. The next one, property 3, says the sum of any two adjacent angles is 180 degrees. Angle B and angle C are adjacent angles. They are next to each other. The sums of those angles should be equal to 180 degrees. So if angle B is 125, that means that angle C has got to be 180 minus 125. 180 minus 125 is 55. So the measure of angle BCD is 55 degrees. Now we need to find the measure of angle A. If you'll notice, A and C are opposite angles. Property number 2 says angles opposite each other have equal measures, which means that if C is 55 degrees, A is also 55 degrees. If you have any questions or need to go back over an example, please hit replay.